Good afternoon, welcome to the webinar going over T-Splines. I thought I'd start off by going through a little presentation explaining about T-Splines and how they can be used in Inventor. So freeform modelling basically incorporates T-Splines. You can create a variety of different shapes in a faster, more efficient way than you perhaps used to be able to do. So you can do quick and easy creation of complex organic forms using T-Spline technology. It's intuitive and easy to use. You've got free-form surfaces with G2 smooth continuity. They're watertight and geometrically accurate, and they're combined with other tools in Inventor, they're incredibly powerful. As you can see from those couple of images there, you can do the really nice kind of complex shapes. Originally, it was a plugin for Rhino 3D and in SolidWorks, digitally sculpt and curve continuous forms. It doesn't require the user to be a surfacing expert. It creates a single unified watertight object. So we look at NURBS, which was sort of the forerunner a little bit. NURBS stands for non-uniform rational B-splines and are basically mathematical representations of 3D geometry that can accurately be used to describe a 2D line, circle, arc, curve, or most sort of 3D organic freeform surface of solids. Sort of the drawback though to NURBS is that they require a lot of control points to create shapes. Sort of as you sort of may have come across in the past, programs that use them are typically things like Autodesk Alias, McNeil, Rhino 3D. So they're some of the most popular ones for utilizing the NURBS format. So the way it sort of works is by using sort of subdivision of surfaces. So as you want to do a shape, you sort of break it down into more surfaces. So subdivision can be found in sort of lots of programs like CATIA, Creo, Power NURBS for SolidWorks, and Maya 3ds, so on. These don't need to be stitched together like NURBS do. So it's a slightly different way of doing complex shapes. So if you want to know what makes a T-spline unique, so it's got T points, which are specific to T-spline, that's where it gets its names from. It's got local detail, and it can utilize non-rectangular surfaces with star points, and it is 100% capability to NURBS. So basically what T-points are talking about, if you look at the diagram on the screen here, is you can have a point going across between a line forming a T shape. So it's like a partial row between, giving you that T shape. So that's where the T-point name comes from. You wouldn't get that in NURBS. So here is two examples of the difference or visually between NURBS and T-splines. So if we look at the frog on the left hand side, you've got 11,625 control points to deal with, and on the right, using the T-splines, the frog has only 5,035 control points. So you can see by minimizing control points, it makes it easier to create models, control the surface smoothness, and decrease the file size and speed up any editing you may have to do. You've also got a limitation to the amount of local detail that you can do with NURBS. So T-splines are slightly easier perhaps to control. You can also have point stars within the T-spline environment, so you can do non-rectangular surfaces nice and easily. So if you look at the diagram here for this sort of enclosure, the two star points enable you to have non-rectangular surfaces, and these are typically created by using commands such as extrude, delete face, and merge. So you can see here how it looks when it converts from one to another. So a nice thing about T-Splines is that all T-Spline surfaces are 100% compatible with NURBS and are gap-free, smooth, maneuverable surfaces. So T-Spline surfaces can be converted to untrimmed surfaces, and vice versa without losing or change to the surface. So you can see there the picture of the 3 ducts. You've got polygon, T-spline, and the NURB duct. So basically, the technology behind it is that every T-spline has a control cage. The control cage is what the user is editing when they model a T-spline. And a nice way of seeing this is you can toggle between smooth, or you can then toggle it back and you see a very rigid shape. Now I'm going to be doing an example to go through this in Inventor Live, and we're going to be toggling back and forth. So sometimes it's easier to work seeing the cage, or it's easier to sometimes see it when it's smooth. So you can go back and forth and work in a nice sort of way just to visually see what you're doing. So the control cage basically acts as a handle underlaying the surface we call the T-spline surface, and basically this is how it makes it smooth. So you can push and pull control cages, vertices, to change the shape of the surface. No matter how much you move the vertices, T-splines will always stay smooth. So the vertices, as you can see on this diagram here, are the lines going between the circular dots. So you can see on the T-spline topology that the T-spline surface are those that have 6 created to an isocurve. So between each of the edges you have a face, and basically each surface is made up of the faces, and you can adjust these and pull them around to create different complex shapes. And you can model in whichever way you want, so you can use a combination of parametric modeling. If you've been using 2015 for a while, you'd have been up to speed with direct editing, where you can just grab a face, move it, re-angle it, pull it out a bit, push it in a bit, rescale it. Or you completely go with the freeform method, where you can just create a shape as a surface in freeform and then perhaps thicken it afterwards, or do a combination of all three. So it's very, very flexible. What we're going to do is look at some of these options we've got in here. In 2016, you've now got this complete ribbon just for doing the freeform environment. This enables us to have an easier screen, less clutter, slightly easier functionality. So you've got lots of tools. I'll just go through them very quickly. You've got conversion, thicken, face, delete face, weld, unweld, edit form, soft modification, match edges, align form, flatten, distance, merge edge, and multi-forms. One I think is quite important to mention here is match edges. What you can do is you can do a 2D sketch on a work plane, and then you can match the edge of your freeform to that sketched profile, so it ties up to a known surface. So it's not all just about pulling it and pushing it. You can actually do it fairly accurately as well to make sure it fits in the criteria that meets your needs. So you can see here by the very shape of this is a car seat we're showing here for a racing car. It's very organic shapes can be achieved very easily. You can also use a center line down the middle to mirror stuff, so lots of things of symmetry, so you can get a very nice symmetrical component created very, very quickly. Much faster than you would have done with just the old-fashioned surface modeling techniques, stitching, and then maybe sculpting as you would have done in the past. Every person will approach freeform in a different way. There is no right or wrong way to design a freeform model, but there are some golden rules to go through, which we'll go through shortly. It does require trial and error to understand and find the form. So what I would suggest if you want to go down this route is start with something simple, have a practice. You'll soon discover what you like and what you don't like, the way you prefer to work, and obviously the ways that you perhaps don't. There is an undo command as well, so don't forget that. You can see on this little window here, it's not clear in this particular example, it's a bit faded out, but in the top, just above the top of the car seat, you can see a little undo arrow, so you can undo within the command itself, or of course you can undo within Inventor as well in the traditional way. So, as I mentioned before, there are some sort of golden rules to follow though. Start by making large edits to multiple faces and edge loops. Next, edit single faces and edges for more refined control. So you're starting big and then slowly making little changes. Finally, edit individual points to make precise adjustments. So you're starting with the bigger picture and working down to make the small changes that you need. So this is what we're going to start looking at shortly. This is going to be the demonstration I'm going to do. So we're going to be looking at a wing mirror for a racing car. Now, one of the key tips as well is to use your view cube. So work in 2D orthographic views. So do your plan, decide the elevations, and work in that respect. Otherwise you can drag things all over the place, but sometimes it can be a bit hard to see exactly what you're doing. And again, you can toggle between smooth and not to see what sort of results you get. You can also try and keep things as uniform as possible. There is what we call a flatten command. So if you look at the one labelled worse, you can see the line's fairly wavy. After you've used the flatten command, you can see on the right hand side it's better. So that'll give you a better finish on your component once it's done. You can place edges or CVs close together with a tight curvature. And if you're going to modify something, always try to use forward sides or faces. And if you can, wherever possible, try and make sure that loops are normal to the form. So you're trying to avoid sort of 45-degree sort of edges. Try and keep things sort of perpendicular or normal. And again, try and get away with a minimum number possible of CVs. So you can see the one on the right is kind of spot on. Basically to the left you've got more work to do. Put a point star in, try and leave it to last, they're more difficult to control. So what I'm going to do now is go in and do the demo. So this is the BAC Mono sports car. What we're going to be looking at is a wing mirror. So we're going to try and produce a wing mirror in a slightly simple form that a customer can come up and use and say, right, I just want you to do this, create a shape. So we're going to do it fairly free form, concentrating on the position of the mirror and going down to the wing. We're just going to create the plastic casing for the mirror. So what I've got here is a surface that represents the wing of the racing car. And in the browser tree, excuse me, I've got a work plane, and I've just drawn on there a rectangle just to represent the rough approximate size of the wing mirror that I want to generate. Now I've only done this to help me work out the position. So to get started, what I'm going to do is go to the 3D model tab. Then we've got the area create freeform. So if we go to the freeform area, go to the drop down, you can see there are some main ones to get started with, so it helps speed us up. So we've got box, hence it's a box type shape. We've got a plane, so it's basically a subdivided surface for us. Cylinder, it's fairly self-explanatory really. Sphere, torus is your sort of donut type shape, and a quadrupole, which is basically a cross between a sphere and a box. So the main ones I'm going to be using for this demonstration are the box and the cylinder. So to start with, I'm going to pick on the box. It's then basically asking me where do I want to place this. So I'm going to say on this work plane over here. So I can just click on it. And then I'm going to use my view cube over this side here. And just make sure I'm looking straight at my job. And then approximately, I'm just going to place the box in the middle. I can then use the arrows to approximately stretch it to the right size. You can see here I can type in exact values if I want to. In this particular example, I'm not too worried, but you can be as precise or as unprecise as you want to. So for the moment, I'm just going to rotate it around like that so I can see what I'm doing. I'm going to grab this arrow and pull it this way. But actually on this side, I've decided that I do want to be a bit more accurate, so I'm going to specify a distance of 100 millimeters and then just go OK. So you can see for the moment, I've got a fairly straightforward and simple shape. It's got 4 faces per side, which means it's going to be nice and easy to modify. I can then pick up my view cube. I then look straight at the object. Excuse me. So first thing I want to do is I can toggle it translucent, and I can then see the position of the rectangle behind, which just gives me a guide. So what I'm going to do is pick a profile like that. I can say edit form, go like that, and then start stretching my component. So I can start moving things down to form the shape that I'm after. So I could say, yeah, that looks reasonably good, so I can pick OK. And then what I can do, at the top here, we've got toggle smooth. So if I do that, it sort of exaggerates a little bit, and I can see, oh, perhaps it wasn't quite as smooth as I wanted. So what I can do is I can just drag that, go edit form, and I can just bring some of the edges either in a little bit. I can maybe drag this one up here, pull that a bit out a bit, go over here, and pull this one in a bit, and just sort of tweak and adjust it so it starts to look a little bit better. Remember, you've got the undo as well, so if I've done something I wasn't quite happy, I can undo it. As you can see, I'm just dragging and dropping, but I can accurately position it because I'm working in one plane at the moment. I can enter the coordinates for the Y and Z, so I can say, well, move that out 2 millimeters, move that up 5 millimeters. So if you want to work accurately, you can do that as well. But for the moment, for this example, I'm mainly just going to be doing it by eye for something that looks about right. So I can say, yeah, I'm happy with that. Toggle it back to smooth. I can then sort of rotate around and say, yeah, that looks reasonable. So what I'm going to do is do a bit more work to this. I'm going to pick these edges up here. Going around. I'm holding control so I can select multiples. But what I want to do is have a flat face. So once I've selected that, I'm just going to go right click, because again in Inventor you've got different right click menus, and I'm going to pick the crease option. So what I've done, I've just put a straight crease down now, so it gives me a flat face to work with. So we see we're starting to slowly develop the shape for this wing mirror for the car. At the moment it looks okay, but I think we can make it look a little bit better. So I'm going to again look straight back at the front. I'm then going to choose some edges, so I can say perhaps I just want no ones like this. I could perhaps then scale that down. I'll rotate that back round so that looks a little bit better. Now we've scaled it in, it's a bit more of a curvature to it. Again, if I can look straight at it, I can then toggle that so it's not quite so smooth. Then scale it a little bit more, whole lot, or I can then remove parts. Scale those separately. So you can see that I'm starting to slowly develop it. So I've got my shape and it's starting to look reasonably good. But what I've noticed here is it's not particularly smooth across the middle. So what I can do, I can pick the lines that I want, and I can just say flatten. And what it's done is a bit hard to see, so it's made those slightly straighter going across. So that's my first initial shape generated. So what I'm going to do is create the connecting arm which goes back down to the wing to start then blending the full component for the plastic housing. So to do this, we're going to generate a new freeform. So I can still do it within the freeform environment. So over to this side over here, I've got create freeform. What I'm going to do from the drop down is choose cylinder. And again, I need to position just initially where I want to create the cylinder. So what I'm going to do is choose a radius first. So in this one, I'm going to be a little bit more precise. So I'm going to say perhaps a radius of 25. And then I'm going to put it onto this work plane and just place it here. Remember, work planes are infinitely long, so even though it doesn't look like I'm clicking on the work plane, it is in line with it. At the moment it's quite short, so it's not making a very good connection, so I'm going to make it a bit longer. So I'm going to type in 300 mil, and that increases the length. What I can also do is uncap it. So at the moment it's got a closed end, both ends. So if I uncheck that box, you can see it keeps the length, but it just makes it hollow. So I'm happy with that for the moment. So with that, I can go OK. I can then look at the end of this, select that, right click and edit form. I'm then going to scale it. So with the scale command, I can just drag it down and it reforms the shape of the pipe. So I'm happy with that one. I can, if I want to, select the whole of the other end. Again, edit form, pick scale, and this time I could perhaps scale up the other end. So there's a bit of a variance in it going across the component. So I can say, yep, I'm happy with that, so I'm going to go OK. So I've got two components. If you imagine that at the moment, this wing mirror is pointing basically straight down the car, because imagine the car's going along in this direction. I perhaps want to turn it so it points a little bit towards the driver. So if I go to the plan view, so I'm going to go to top, I can see that I want to rotate it counterclockwise just a little bit. So I'll go edit form, I can pick that component, and up here, if I hover over this little dot appears, I can just rotate it by a number of degrees. So rotate it at 10 degrees. And like I say, I'm happy with that. I can then move this one across and then rotate this one as well. So I can say that's at 10 degrees. I can say I'm happy with that. So I've started to roughly position where I want things. Within this environment now, I want to start shaping this component. So what I'm going to do is choose how I filter what I'm selecting. So at the moment it's picking all of the intersections between the vertices. So what I'm going to do here is pick this option, the second one in. So I'm just going to select the lines going between. And I can then just drag up the shape and vary it a bit. So I can see that's going to look slightly better. I can then pick that one and adjust the angle. Because remember before I could try and keep the edge normal to the surface. It works slightly better. But again, I've just done it in this plane. I can say OK for that for the moment. I'm then going to rotate this round, and then I want to bring this down so it goes below the wing for the moment. So again, I can just pick that edit form and bring it down below the surface. Again, I can rotate with the view cube. You can see it's from this direction, it's not in the right place. So again, I can just pick the profile, edit form, and this time bring it across. So this time I can rotate around and just double check it is completely through. So we're starting to get a nice complex shape developing for creating our component. Obviously at the moment there's a big gap between the two, so what I want to do is bring these two components together, form one component. So to start with, what I'm going to do is delete these four faces. So I can press Control and pick the four. I'm then just going to go right click and delete. Alternatively, you can go up to the menu up here and delete. You can work in whichever process you find most comfortable. So I'm going to delete that. You can see it automatically shifts a little bit. What I'm also going to do is just make sure that we've got a flat face there. So you can see it here, flat, go OK, and it's just tweaked them all a little bit. So go to the right hand side, go to the top. What I can do is I'm going to select these, edit form, and I can then stretch or scale the components out a little bit. Next thing I'm going to do is join these parts together. So there's two different ways of joining things. You can either bridge, and I can say how many faces I want, so I can say bridge that surface, then to number 2, this one over here, and I can say perhaps I want to put in 5, go OK, and it adds in additional faces. But it won't always give you the result you want. I think in this case it's not ideal, so I'm going to undo that one. What I am going to try though is perhaps merge. So that one to this one here, and you can see there it gives me a much more sort of visually pleasing result. So it's just basically stretched the surfaces across to each other. So I'm going to say OK. However, again, you can notice on here we've ended up with some rather wavy type lines. So what I'm going to do is select those, go flatten, and you can see there it's straightened them all up a little bit. So we've now got a shape which is smooth, joins. It's a much more interesting shape to look at. That's the basics to get started with. What I'm going to do now is try and make it into more of a solid now. So I'm going to delete these 4 end faces. This time I'll do it from the top menu instead. So now we've got a completely hollow surface. If I just finish it and go back to the model environment, you can see it's orange here. I can make it translucent so you can see it is just a surface. But obviously created in a very different way to perhaps one you may be used to doing within Inventor. So you can go straight in and use the thicken command within this environment. However, what I'm going to do is go back into the form, and you'll notice within here we've got a thicken option as well. So I'm going to pick thicken. I'm going to pick the surface, and you can see by default it goes one side or the other. So I'm going to make it go inside. I'm going to say I'm happy with 2mm. You've also got the type of edge you want, so you can have a soft edge, or flat edge, or a sharp edge. Oh, sorry, no edge at all. But I'm going to stick with the default one and go OK. So I'm going to finish that freeform. You can now see we've got a solid shape we can utilise. I want to turn off the visibility of the sketch. So that is the basics behind freeform modelling. Now the next steps I would do, if I was going to finish off this particular component, so I would trim up this end here, and then you can start developing maybe a place to insert the mirror and develop the shape. But what you've got there is a very nice, smooth, quick and easy way of developing some shapes. So that's a very sort of quick and easy way of creating the components. It's a bit quicker than I was perhaps intending to go through. So what I was going to propose is, if you've got any questions you'd like to ask, please feel free to type them down, and I'll do my best to answer any that you may have. Okay, so far there's no questions. I'll give you a couple more minutes if you want to ask one, but I'd like to take this opportunity to thank you for looking at this webinar. I just see a question come in, bear with me a second. So talking about can you use functionality to put in more dimensional control into an object? Yes, you can. You can snap an object to a sketch. So for instance, if I create a new part very quickly, I can do a traditional type sketch. So I could say that's going to be, I don't know, 50 mil. So that's fully constrained. I can then go in and maybe put in the cylinder. I can pick that surface. Again, I can specify a radius, but I can make it smaller in this instance, perhaps. I can pick where I want to place it and do something like that for the moment. So you can see at the moment that doesn't really tie up with the surface. But what you can do, if I go into here, I can use something called match edges. If I pick that, I can say the edges I want to match, I can click them. I can say the target is going to be this sketch, and it brings it in and draws it into that component. So if you've got a certain profile that you want your component to match, you can then tie it in. So you can obviously put a parameter to this dimension, and that will tie it in nicely to it. Later on, sometimes parts might move away, but then you can always go back in and refresh that command. So within here, you've got your matches. So in the future, if I sort of tweak the surface and it didn't quite line up again, you just go back into the command and then find these matches and rematch them back to that sketch. So if I modify this sketch, maybe make it a bit smaller, it doesn't match. So what I'll do, go back into my freeform, find the edges I want to match, and go rematch, and it brings it back in again. So hopefully that answers the question in a bit more detail. Is there any other questions at all from anyone? Okay, well again, I'd like to say thank you very much for attending this. If you do have any questions, please do not hesitate to get in contact with us. If you go to the Graitec website, we've got contact details on there. And I'd just again like to say thank you very much. All right, thanks then.